paper of April 2023. Question number 7. April 2023, question number 7. Part A, explain the meaning of the following terms in the context of probability theory. Number 1, mutually exclusive events. Mutually exclusive events. We said that these are events that cannot take place at the same time. These are events that cannot take place at the same time. Full stop. They are described by the word all. They are described by the word all. E.g., boy or girl. Boy, girl. Number 2, independent events. Independent events. Independent events are events that do not influence each other, are events that do not influence each other and can happen at the same time. And can happen at the same time. E.g., eat or eating and walking. You can be eating something and you're walking. It can happen at the same time. Part B, a linear programming problem has been formulated as below. So we have the objective function, and we are told to get the optical production for X and Y using the simplex method. Using the simplex method. So we are using the simplex method. I told you the first step is always to come up with the formulation, and the formulation has already been done. So what we are supposed to do is now to do what we call the changing the inequalities to equalities. So changing inequalities to equalities. Changing inequalities to equalities. You can see we have three resources. So we'll say let S1 to be the slack variable for resource 1. S1 to be the slack variable for resource 1. S2 to be the slack variable for resource 2. S3 to be the slack variable for resource 3. Then objective function is to maximize Z, which is equal to 14x plus 10y. Then you bring the slack variables, 0s1 plus 0s2 plus 0s3. Now this is subject to 4x plus 3y plus s1 should be equal to 240. Then 2x plus y plus s2 is equal to 100. Then 0x plus y plus s3 is equal to 50. That is how it is supposed to be designed. Then kutoka hapo, you develop what we call the initial simplex table. The initial simplex table. Initial simplex table. So in the initial simplex table, I told you we prepare column C, that is the first one. Then we have the basis. And in the basis column, we bring the S's. So this is S1, S2, S3. Then you bring CJ, ZJ, and DJ. From there, these items that are in the objective function, they become the titles of your columns. So I have a column called X there. I have another one called Y. I have another one called S1. I have another one called S2. I have another one called S3. And the last one I told you is called BI. It's called BI. And then this space is left in case we may need to compute the ratio. In case we will need to compute the ratio. So now we put these values for the S's, the contribution margins are zeros. These ones. And then S1, you bring these values here, 4, 3, 1. So we have 4, 3, 1, 0, 0. And the total here is 240. Then this one we have 2, 1, 0, 1, 0, and 100. Then for S3, it is 0, 1, 0, 0, 1, and 50. And then I told you that for CJ, we bring these coefficients here. So this is 14, this is 10, this is 0, 0, 0, 0. And then ZJ, I told you they are zeros. They are zeros. Then this one, when you multiply, you just bring, or when you subtract, because CJ, when you subtract ZJ, you get DJ. So 14 minus 0 is 14. This is 10, 0, 0, 0, 0. So remind me now, is that table optimal? Is that table? Yeah, good. I can see you are saying no. So we said what you do, you pick the highest value. So this is the highest here. And when we pick the highest, we say this value is called the incoming, the one that is there at the title. Then you divide value here using the values in the key column. So like now, this will be 240 divided by 4. Tell me 240 divided by 4 is what? You can speak or chat. It is 60. Then 100, you divide by 2. That gives us what? That gives us 50. And then 50, you divide by 0. That gives us something called infinite. Infinite is a very high value, but it's unknown. Sasa, most likely your calc is giving you math error, but that is the way it's supposed to be. So now, I told you you pick the smallest. So the smallest of these is this one. And that becomes our key row. Where that key row meets the key column, this one is called the key element. Na hii nayo tukasema is called the outgoing. So we are going to design a new table. We are going to design a new table now. We're going to design a new table. Which we are going to call the second simplex table. Let me see my table, my board imefika mpaka wapi. But I use it there. This one is DJ. Let me start down here so that I get enough space. ZJ, CJ. So this would be S3. Now this S2 will be replaced by X. So this will be X, and this is S1. So I need the title one. So now we are drawing the second simplex table. So this is column C, this is column basis. So now we said that the titles of these columns remain. So column X remains, column Y remains, column S1 remains, column S2 remains, column S3 remains, column BI remains, and in case there will be need, I will have a space for the issue. In case there will be need. Henry, we are dealing with the question of April 2023, question 7B. That's where now we are. April, oh, where I've written is not visible. April 2023. So if we are there now, we are there. I told you the next thing you do, unakuja kwa hii. You divide everything by the key element. So you say 2 divided by 2, that is 1. So unaiandika hapa. 2 divided by 2 is 1. Then hiyo ingine unasema 1 divided by 2, 0.5. 0 divided by 2 is 0. 1 divided by 2 is 0.5. 0 divided by 0 is 0. By 2 is 0. And 100 divided by 2 is 50. And we said that this becomes our new row. Our new row. So to get the values for the other rows, tutakuja hapa tukianza na hii odd row S1. So utasema odd row S1 value. Odd row S1 value minus new row value minus new row value times balancing figure times balancing figure times balancing figure, it will give us new row S1 value. Old row S1 value minus new row tuanze na hii. So the new row, the old row, we have 4, we have 3, we have 1, 0, 0, and 240. So you say minus, 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 minus. That way. Alafu unaleta hizi, the new row, which is 1, 0.5, 0, 0.5, 0, and 50 times. So unasema times, kila mahali, times. Times the balancing figure. I told you balancing figure is the value at the intersection. The value at the intersection of the key column and the key row, or the old row that you're dealing with. The value at the intersection of the key column and the old row that you're dealing with. So that is 4. So put 4 there. That way. So when you put 4, I told you if you do not want to confuse, just pick the calc and keep in the values as they are. So let's go. 4 minus 1 times 4 equals what? Give me the figures. Taking too long. Yeah, 0. So that 0 ndio ninaweka hapa. Tuende kwa hii ingine, 3 minus 0.5 times 4. 1. The next, 1 minus 0 times 4. That is also 1. The next is 0 minus 0.5 times 4. Negative 0, negative 2. Next, this one obviously will be 0. And the last one will be what? 240 minus 50 times 4. $40. Good. Sasa, let us do the same now for S3, old row S3. So the formula now will be old row S3 minus new row value times balancing figure is equal to new row S3. New row S3. So sasa, The old row is 3, ndio hii. Iko na 0, iko na 1, 0, 0, 1 and 50. Then you say minus. You say minus. Now minus the new row. This is 1, 0.5, 0, 0.5, 0 and 50 times the balancing figure. So the balancing figure is this one. It is 0. So if it is 0 here, kila mahali, this one remains as 0. This one remains 1. This is 0. This is 0. This is 1, and that is 50. Sasa CJ, I told you the values for CJ, they remain constant. So put 14 here, put 10, 0, 0, 0, 0. Values of CJ, they remain. Then, if the values remain, let's put these values here. The contribution margin for S1 we know is 0. For X we know it is 14. For S3 we know it is 0. So we now start to compute the values of Z. The values of Z. So for the values of Z, I told you we take these values, we multiply. Like now, here kwanza, it will be 0 times 0 plus 14 times 1 plus 0 times 0. And the answer obviously will be 14. So your 14 will not happen. The answer will be 14. Unakuja kwa hii ingine, unasema ni 0 times 1 plus 14 times 0.5 plus 0 times 1. So this obviously becomes 7. And as you can see, because these two are zeros, tumebakishiwa tu hii kumultiply. So this one I'll write 7. 14 multiplied by 0, that is 0. 14 multiplied by 0.5, that is 7. 14 by 0 is 0. Tell me 14 multiplied by 50 is what? 14 multiplied by 0 is what? $700. Good. So now, between 700 tulisema DJ is equals to CJ minus ZJ. So 14 minus 14 is 0. 10 minus 7 is 3. Then huyu mwingine ni 0. Huyu ni negative 7. Huyu ni 0. Na huyu ni negative 700. So is that table optimal now? Yeah, I can see I'm told it is not optimal. Good, because we have a positive value here. We need all of them to be negative or to be zeros. So that when you get logged out, you log in. Now that gives us the leeway now to make the third simplex table. Good. So I'm making now the third simplex table. And in making the third, I obviously have column C here. Then I have the basis. And how will I know the basis? Tulisema, this is what you do. You pick the highest value here. One. So this becomes the incoming. That title there. Then you create the ratio. The ratio is, come up, it will be 40 divided by 1. 40 divided by 1, that is 40. Then this one will be 50 divided by 0.5, that is 100. This one will be 50 divided by 1, that is 50. So we pick the smallest. So the smallest is this 40. We pick the smallest, which is 40. The value at the intersection here, that becomes our key element. And this one here becomes the outgoing. So when I go to my third table, S1 will be replaced by Y. So this now becomes Y. This remains X. This remains S3. Then I have my CJ, my ZJ, and DJ. Then I can bring the contribution margin of Y. No, it is 10. This is 14, and this is 0. So we start now to create the columns, and I told you the columns will remain. So I have a column called X, another one called Y, another one called S1, S2, S3, and BI.